So Google's TabFM, which is the first foundation model built specifically for tabular data, is really impressive. So I actually gave it a real test in my Colab and I ran it against XGBoost. And I used a real data set from the industry, which in this case is the churn data set from IBM. Now, this will be a little bit hard, so I prepared a visualization to explain this. So this is a data set which has got 7,043 telecom customers. Every single dot is one of them. So you can see that it has a mix of customers by contract, by tenure, price versus tenure, as well as by internet service. So you can see that there's both numerical as well as non-numerical. Now, if you look at my results here, and I'm going to go through this Colab in very, very detail in a few minutes from now, but this is the summary of this, right? So you can see that TabFM really outperformed XGBoost, not only in accuracy, but also in other terms like AUC, which is area under curve, and also in terms of efficiency, right? So you can see the columns used by TabFM is very low. And this required zero training, okay? So clearly TabFM performed really better. Now, in my last video, I explained how TabFM works under the hood, and that one is linked above, and I'll also share it in the description. In today's video, it's going to be a little bit different. Today, we are actually going to run it cell by cell in this particular Colab notebook that I showed you so that you can follow along and run every single thing on your own data and build this on your own. As this was one of the biggest asks from last video. Remember, this is not licensed for enterprise use or commercial use, but you can definitely use it for your own personal learning, okay? And in case you missed that first video, no problem at all. Here is the quick context. And if someone has seen that video, you can skip ahead. Now, what is TabFM? So think about this. Most of the world's business data lives in tables. Think of customers, transactions, churn, risk, spreadsheets, all of that, right? And for years, the rule was if you want predictions from a table, you have to train a model on that table. Every data set needs its own model, its own tuning, and a pipeline somebody has to maintain. Now, TabFM kind of breaks that rule. Google pre-trained it on hundreds of millions of synthetic tables, so it has never seen a single real one. And instead of training on your data, it just reads it. So you hand it a few hundred example rows, the same way you would paste examples into a prompt when you're talking to a large language model, and it predicts the new rows in one pass. This one is called in-context learning, and it's the whole reason that there's nothing to train. And the top comment on that video said, "Great theory, now prove it on real data." So fair, let's settle this, okay? And the setup is strictly even. So we'll look at both sides of this, where TabFM wins, where the old champ hold its grounds, and at the end, I'll throw TabFM a completely different spreadsheet live to show this works beyond one data set. And if you're meeting for the first time, I'm Surya. I have over 2 decades of experience in big tech, leading multiple teams in the AI, ML, and cloud space. Every week, I try to release interesting videos on the latest in AI. And if that's valuable to you, please subscribe. All right. One quick disclaimer before we move forward. All opinions are my own and do not belong to my employer. All right. With that, let's get into it. All right. So what you're seeing right now is the Google Colab that I've created, and I'll walk you through step by step on how we can use TabFM to predict with the data set. All right. First things first, you need to go here and change the runtime type to T4 GPU. It's better to use GPU versus CPU. That way you will be able to run this faster. And remember, this is a large model. So since you're downloading this from Hugging Face, this will help. And this is also free of cost. So why not? So the first step here is to install TabFM. So I'm going to run this so that we will install TabFM. This is GPU and PyTorch as the backend. So you're seeing that the libraries are getting installed. Okay. So we'll give it a second. And then once I'm done with the installation, I will restart the runtime. Okay. So if you get an error message like this, you can ignore because the installation is already done over here. Okay. So now I'm going to just restart the session and then I'm ready to load the model. And also we'll set up the chart style, right? Because I wanted to also show you the visual side of the house. So what we will do is for anything which is TabFM related, we will choose a different color. For anything which is XGBoost related, we will choose a different color, and then churn versus state, right? So this is the same data set that I just talked about. This is the IBM's data set over here. This is the raw one, right? So this has got the output, which is churn, yes or no. So you can see this here. So that's what we're going to be using. So whoever has churned is red, and then whoever has stayed is green, and then because we are competing between two different models, I want to show you one in teal color and the other one in orange. Okay. So right now it's loading the model and also setting up our charts. So we'll give it a few seconds and then we'll come back as soon as it is done. So if you already have a Hugging Face token, then you could actually add that as a key over here as the Hugging Face token and it would work faster. But if you don't have it, as I'm showing you that I'm running it without the Hugging Face token, it still runs. It just might take a little bit more time. So it has loaded the model. Now let's look at the data once again. So as I had shown the data in a very unstructured format here, but you can see that this is the structured data, 7,043 customers, 21 columns. This is the entire data set. You can see this over here. Okay. Now, we can also ask some basic questions. For example, how many customers churned? So you can see the actual churn versus stayed customers in terms of the percentage, what's in a customer. So these are all the different features by type. So these are some of the questions that you can add. These are more statistical questions, right? So churn rate by contact type, you can see that month to month is a higher churn rate, etc. And then you can also find other signals, again, customer tenure by churn outcome. So this is even before using machine learning or TabFM to get some sort of an answer. So this is pre-analysis that an analyst would do. But then this is where the part becomes interesting, which is using TabFM with zero training. So what we're going to do here is we are going to split once, which is 300 customers as context, and we will keep 100 held out data for testing. We will use exactly the same data set for both models, and we will use the 300 in the case of TabFM, which will use it as in-context learning, but XGBoost will use it for training, right? So there's a bit of a difference, which is a big difference. But in the case of XGBoost, it is going to build like multiple trees, right? In the case of TabFM, it is just going to use this to in-context learn, and then in one pass, it is going to predict, right? So that is a basic difference. So TabFM already ran, because we're using GPUs, it was very fast. And you can see that it is 76%. And then you can ask some more questions. TabFM predicted churn risk by actual outcome. Other questions that you can ask, highest risk versus stuff like that. So I went into a bit more detail here to figure out if TabFM can be more helpful in some other questions as well. Now, this is where it becomes very interesting when you apply TabFM versus XGBoost directly. So XGBoost accuracy on the same one is 74%, right? Now, the raw columns used in TabFM was this, and this in XGBoost was 45. So you can see that columns used in XGBoost was way higher than TabFM. And this is the AUC, which is the area under curve scorecard. So you can again see the difference here. And now this is ROC curves. The higher, the better. Again, TabFM does a fairly good job over here. And this is the confusion matrix. So you can see again, TabFM is doing a fairly decent job, but there is still scope of improvement in this quadrant. And then finally, the final scoreboard is this, which is what I showed you in the beginning, which is the accuracy, AUC, columns used, prep needed, none, which is very critical, right? Prep needed in the case of XG boosting, you need to do a one hot encoding and stuff like that, right? And then there was a training required as well, right? So this is what I wanted to show you as part of this exercise. Now, what we can also do is I actually ran it with the Titanic data set, which we are all familiar, right? Which could be an interesting test as well. So let's see how TabFM performs here, right? So you can see that these are two different data sets altogether. So this is the Titanic data set which we're using. The earlier one was churn data set. The point which I'm trying to prove over here is that TabFM can literally work on any structured data set, which is in a tabular format, which is why it is called TabFM, right? So which is tabular foundation model. So let's see how it performs with the Titanic data set without any training, and we will get to see the answer pretty quickly. So we'll wait for a second for it to come back with the answer. Oh, it did. So accuracy on 100 unseen passengers, 88%, right? So this is again fantastic. We just provided the data set to TabFM and it just ran. Okay. So that's the idea that I wanted to convey. You can clearly see that there is a lot of potential with this. What I feel is, will this completely replace the sophisticated machine learning? I don't think so, because you still need to do a lot of data preparation, a lot of data cleansing. You still need to have that business understanding. Once the data set is very structured, yes, you could use this. But then if you have to do ensemble modeling and all of those kind of things, I think this may not be applicable just yet. So my recommendation is use TabFM to quickly see the results and understand where we are going with this in terms when you have a structured, cleaned data set. Otherwise, continue to run your machine learning models. This field is going to keep on getting better and better. So I think this definitely reduces some portions of the machine learning, but not completely changes it all. There's another interesting model which is called Times FM, which is specifically built for forecasting. So if you want me to build a deep dive on Times FM, let me know and I'll be happy to run you through that as well. All right. I hope this was helpful. This was more of a practical implementation kind of a video where I wanted to take you through the entire code so that you can build it out yourselves. All right. So hoping that this was helpful. Do let me know in the comment section if you guys have any questions. And if you're new here, please hit that like and subscribe button as well. Thank you very much for your time. Thank you for watching. And I will see you in the next one.